All right. At 2, this thing is not defined, because when you plug in 2, you get 1 over 0. But the fact that we get 1 over 0 when you plug in 2 means that there's not a hole there, there's a vertical asymptote. This function actually looks like this. If you graph this, at 2 there's an asymptote like this, and the function looks like this. So no matter what point we force f of x to be at 2, no matter what value we give it, or g of x, I guess, because that's going to be our new function. Like, there's nothing we can let g of x be at 2 so that this thing's going to be continuous. So for the other examples, we did this. Oh, it equals this everywhere except for 2. Well, that's all fine and dandy. But then we had to say, what is the limit? What's f of x approaching as x approaches 2? Well, it's not approaching anything. It's approaching infinity from the right and negative infinity from the left. So no matter what I do here, I cannot make the limit equal the function. So I can't make g continuous because the limit doesn't exist. So we cannot extend f of x to make it a continuous function. This is not going to work. And the reason is, to explain why this cannot be done, because the limit doesn't exist at 2. The limit as x goes to 2 of f of x doesn't exist. And if the limit doesn't exist, then it can't be continuous. And we can't just extend it to make the limit exist. We can't add 1 point and make the limit exist.